Okay, so let us see how we handle this question. Now we are going to see how we handle when the particle is inclined at a certain angle to the horizontal. Let us go through this question. A particle of mass 8 kilograms resting on a smooth plane inclined at 30 degrees. Okay, so we have 30 degrees here. This is our plane inclined at 30 degrees. But we have a mass, or a particle of mass is here. This one is having 8 kilograms. Of course, the way, okay, let us start with that. Attach a string passing over a smooth pulley at the edge of the plane. So this one is attached to a string which again pass over this pulley like that. Then they are saying, if the string is also attached to a 12 kilogram mass, I mean 12 kilogram particle below the pulley, so it has a 12 kilogram mass or power below the pulley. This is the 12 kilogram particle below the pulley. Find the normal reaction to the 3 kilogram mass particle, acceleration of the system, and the tension in the string. Okay, so whenever we have a body, we are going to be having a reaction. So this is going to be our reaction. Because the plane is smooth, we don't expect anything like friction. So it's smooth there. So we expecting, first of all, we are going to see that this force is going to be having a weight acting on it, which we said is going to be the mass times the gravity. And we said if we resolve this force, we are going to resolve it like this. And we say this one is going to be the adjacent if the angle, remember this is our angle theta, 30 degrees. So if this is 30 degrees, then this one is going to be adjacent, so it will be 30. Sorry, not 30. It's going to be the weight. I will start it with the angle. But it's going to be the weight, this weight, so we have 8d, then cos of 30 degrees. Then the opposite is going to be, if you draw another opposite like this, it's going to be part of this. So that's why we put it here. So this is going to be 8d for its opposite. That's why it goes with 30 degrees. Now, of course, we expect a tension in a string being pulled like that. Then this one, also this, we have a tension also there. After summarizing a diagram like that, then life is very easy. So they are asking us to get, unless there is anything we're missing, I think we have put everything there. Find the normal reaction to a 3. So they want to an 8 kilogram, this is 8. To the 8 kilogram mass particle. So this is the reaction. So if you resolve that, we start our reaction. Forces normal to the 8 kilogram mass. So we said forces normal. Normal means perpendicular. Normal to 8 kilogram particle. So what are they? So we are going to be having, or is our force R is equal to ma. But remember, this particle here is not moving in this direction, it's just going like the other side. So meaning that their acceleration upwards is 0. So now we are going to be having, or is our R minus this one, 8d cos 30 degrees equal to n equal to 0. Because this side there's no acceleration, so always our R will be 8 into 9.8 cos 30 degrees, and our R here is going to be minus cos 30. So I'm getting 67.896. 4. We give it 2 to previous more places. I mean 4 is It's a force, that's why you put newtons. Okay, now after that they are asking the acceleration of the system. Remember now this force, now our acceleration is going to be in this direction here, because the force is going to be like that. Okay, then also let us slide up. Now this body is going to go in that direction A. Our acceleration like that, as simple as that. Because this weight is going to be pulling the whole of that. So now, from there, if we start now to the forces on 80 kilogram mass. So remember, this one is also going to be having its weight as 12g. So if you start with 8 kilogram mass, okay, let's start with the 12 kilogram mass. 12 kilogram mass. Where's the acceleration going in that direction? So our acceleration is going in this direction, A. So it means that now the resultant force will be equal to M times A, using the second because it's low. Now, so what is pulling it in this direction is the 12 kilogram. Is the weight, then minus the opposer. This one which is saying we are going up. It's going to be equal to the mass, which is 12 times the acceleration, and we call this equation on yeah. 1. Then now this one we are now going to our acceleration sits acting along the plane. So that 8 kilogram mass, we start now their acceleration is acting along the plane. Sits acting along the plane, going to the other side. So meaning if you resolve these forces, still our Fr should be equal to Ma. The resultant force is equal to the mass of the particle times the acceleration of the particle. Because it's the same spin, we expect the acceleration to be the same. So now the resultant along, so we are going like this. First of all, we have the T in that direction. Is there anything opposing? Yes, we have opposers. We have this one saying I'm going this side, 8g sine 30 degrees equal to the mass of the particle, 8, then times the acceleration. Of course, we know that sine 30 is the same as a half. Sine 30 is the same as a half. So putting it there, then minus 8g into a half equal to 8a, which you can every do without doing all this. So our t then minus 4g is equal to 8a. I call this equation 2. Now the question is basically done. I think everyone can solve this and this. What are you going to do? We are going to get this and we add it on this so that we can easily get our acceleration. So we say 1 plus 2. We shall get our 1, which is 12b minus t equal to 12a. Now we are going to rearrange. Start with this one. The negative 4g, so negative 4g, then plus t equal to 8a. Then we are adding this. So we add this one is going to give us 8b. This will go to 0, and here we have 20a. So that my acceleration is going to be, you can divide by 4. By 4 here you have 2, by 4 here you have 5. So 2 over 5 g. We have g. Our g is going to be 2 over 5, then times 9.8. So our a becomes 19.6 over 5 meters per second square, which you can give for the small places. Now if I have this, I think I cannot fail to get tension. So from equation 2, allow me to bisect. From 2, you see my tension is going to be 8a, then plus 4b. And this time, so this is going to be 8. My acceleration is 19.6 over 5, then plus 4 g. Oh, I would have put it here then life would have been easier. Okay, my G. From here, my A. Yeah, let me not take a lot of time. Let me just get it in that order. Okay, you see that from here, my A was 2G from here over 5. This was 4G, so that I can easily simplify. So my T here, when first one is going to be 20 plus 16, that is 36G. That's 6G over 5. So my T is going to be 36 over 5 into 9.8, which you can give 2 for decimal places. Okay. 36 times 9.8 divided by 5. So here I'm getting 70.56, and these are newtons. This one here, our acceleration, if we had to complete that, our acceleration here is going to be, our A here is going to be 3.92 meters per second. And now the number is done. So that's how you handle that. As long as you know how to resolve, life is going to be very, very easy. I think I can wish you well. We are going to see the next lesson, but please don't forget to subscribe to the channel.